All right, so today's lesson, we're starting Unit 5. Today we're talking about special right triangles. Special right triangles. Okay. So whenever we have special right triangles, there are two of them. You're awesome. Thank you, sir. Two types of right triangles are special right triangles. The first one is when the angle measures are 45, 45, 90, and this is called an isosceles. Right triangle. Isosceles right triangle. So when you have an isosceles right triangle, two of the sides are the same. Two of the sides are the same. These two sides that are the same are called the legs. So I'm going to mark these two pieces congruent to each other. And just so our notes are the same as the filled out notes, I'm going to just say that this leg measures 4. We're going to come up with the rule. So if this leg on the left is 4, and it's an isosceles right triangle, what does the leg on the base have to be? 4. So you guys use Pythagorean theorem to solve that. So let's do that same thing. So 4 squared plus 4 squared equals, can I call this x? X squared. So what is 4 squared? 16 plus 16 equals x squared. And 16 plus 16 is 32 equals x squared. How do I get x all by itself? Say it. Yeah, I have to take the square root of both sides. Square root. So the square root of x squared is x. But I have to break up 32. I have to write that the square root of 32 as a perfect square. 8 and 4. Okay. So square root of 4 times the square root of 8. What is the square root of 4? 2. Okay. But I can break the square root of 8 up into what? Square root of 4 times the square root of 2. And so what is the square root of 4 again? So I really have 2 times 2 times the square root of 2. What does this simplify to? 4 times the square root of 2. So I want you to look at the value of the hypotenuse, which is 4 root 2, and the value of the two legs. So how do they compare? How is the measurement of the legs different than the measurement of the hypotenuse? Can everybody look up there? What are the measurements of the legs? 4. And what is the measurement of the hypotenuse? 4 root 2. So that's the rule. That's the pattern. Okay. So when the measurement of the leg is A, if the leg has a measurement of A, then the hypotenuse is A times the square root of 2. This is the rule for 45, 45, 90 triangles. Hypotenuse is whatever the leg is times the square root of 2. Okay. So we have another type of triangle. We have another type of triangle that we call special. And it also follows a pattern. They're special because they follow specific patterns, okay? This other type of right triangle that we're going to talk about is a 30, 60, 90 right triangle. And it doesn't have a special name like isosceles. But I'm going to tell you that this I'm going to call 5. And I'm going to give you this measure of 10. And I'm going to ask you to find, I'm going to call it y. Let's solve for y. So I set this one up a little bit differently. How am I going to solve this one? Still going to use Pythagorean theorem. Hopefully we see a pattern. Yeah, 5 squared plus y squared equals 10 squared. What is 5 squared? So 25 plus y squared equals 100. Okay, now what? When I subtract 25 from both sides, I find out that y squared is 75, right? Because 100 minus 25 is 75. Chandler, are you with me? Get your head off your hand so you stay awake. Square root of both sides. Y equals square root of 75. Can we break that up? How can we break up the square root of 75? $15 isn't a perfect square. Destiny, you've got out your green sheet. 25. And what else? I'm sorry, I cut you off. Perfect. Square root of 25 times the square root of 3. What is the square root of 25? Y equals 5 root 3. So that means that the long leg, that's what we just calculated, is 5 root 3. Do you guys see a pattern between the short leg, the long leg, and the hypotenuse? Do you see a pattern between the short leg, the measure of the long leg, and the hypotenuse? I heard you say yes, Quali. What is it? What? Not by 2, but by what? Yeah, they're all multiples of 5. So if we start with the short leg and we call it, I'm going to just call it, I don't want to write a B because it's going to look like it'll end up looking like a 6 or something. How about if we call it G? We call the short leg side G. This is just going to be the rule. If the short leg is side G, how would you describe the long leg? What did I do to go from 5 to 5 root 3? What did I add or multiply by to go from 5 to 5 root 3? G root 3. G times the square root of 3. So I just took whatever measure I have for the short leg, and I multiply it by the square root of 3, and that gives me the measurement of the long leg. Okay? What about the hypotenuse? And I would compare it to the short leg. Compare the short leg, which right now is 5, to the hypotenuse, which becomes 10, and tell me in terms of G, what did I do? 2G. So this is the rule for a 30, 60, 90 right triangle. Okay, this is the rule for 30, 60, 90 right triangles. So we're going to use that rule, but we can also use Pythagorean theorem every single time. I'm just trying to show you a shortcut, right? These are two special types of right triangles. So 45, 45, 90 means that you have two angles that are 45 and one that's 90. 30, 60, 90 means you have an angle that has a measure of 30, an angle of 60, and an angle of 90. So let's do some practice. So let's think about what the rule was. So if both of the sides are the same, If both of the angle measures are the same, then the sides have to be the same. So if the base of this triangle is 7, I know that it's congruent to the other leg, which has a measure of what? 7. So, no, well, hang on a second. So both of these are 7. So go back. I want you to look at your notes at the 45, 45, 90. If you know the measurement of the leg, what did you do to that to get the hypotenuse? If you know the measurement of the leg, look at the rule. What did you do to find the hypotenuse? I don't add root 2. Yeah, I'm taking the measurement of the leg and I'm multiplying it by root 2. So if the measurement of the leg is 7, 7 times the square root of 2 is 7 times the square root of 2. Let's look at this next one. This side right here is the hypotenuse. This is the hypotenuse. And if I want to use the rule, it says that the hypotenuse equals what? Someone tell me what the rule is that we just wrote for the hypotenuse on a 45-45. Okay, so tell me exactly what you wrote for the rule. What did I say? The rule is what? Hypotenuse equals A times the square root of 2. So 8 equals A times the square root of 2 because 8 is the hypotenuse. Does that make sense? I'm just using the rule. Yes or no? Okay, so let's use that. 8, the hypotenuse, equals A times the square root of 2. I'm trying to solve for A, which will actually give me the measurements of X and Y, these two sides. How do I get A all by itself? What is the undo of multiply? Divide. So I have to divide both sides by what? The square root of 2. Okay. Vanessa, are you with us? Because it looks like you're sleeping. So I have 8 divided by the square root of 2 equals A. Can I leave it like that? Am I allowed to have a square root in the denominator, Dylan? Is that allowed? Okay, I need you to face the front, Dylan. So change the way that you're leaning and lean towards the front. Thank you. So how do I get rid of the divide by a square root? We've done this. We've simplified radicals. You cannot leave a radical in the denominator. How do I get rid of that? No, that you take out an I if there's a negative. There's no negatives under the radical. How do I do that? Well, the undo of divide by the square root of 2 is multiply, right? So we're going to multiply both the numerator and the denominator by the square root of 2. We've done this. It's called rationalizing a denominator. We're just multiplying by a fancy looking 1. The square root of 2 divided by the square root of 2 is just 1. Okay? So when I do that, I have 8 times the square root of 2, which is just that, 8 times the square root of 2. But what is the square root of 2 times the square root of 2? Square root of 2 times the square root of 2. You have calculators in front of you. If you don't know the math, if you can't look at it and do it, then put it in a calculator. What is the square root of 2 times the square root of 2? What'd you get, Zachary? I got 2. That's correct. It's 2. Okay. So can I simplify that? Can I simplify 8 square root of 2 divided by 2? Is 8 divisible by 2? Yeah, it becomes 4 root 2. So A equals 4 times the square root of 2. So that means that each one of these sides equals 4 times the square root of 2. Each one of these sides equals 4 times the square root of 2. Let's do the next one. This is a 30, 60, 90 right triangle. So I know that this is the short leg. This is the long leg. And this is the hypotenuse. All right. Aubrey, if you look at the rule that we just wrote down for the 30, 60, 90s, if you know the short leg, how can I find the hypotenuse? So it's 2 times whatever the short leg is. And 2 times 2 is what? Okay. So my hypotenuse is 4.
So I didn't get all of that right there. Because it comes up with, but why do I?
Here, because I used G, but on those it says Y, just so you know. You just copy it down. I just gave it a variable. So if I know the short leg, is 2, what is the measurement of the long leg? Look at your rule. If I know the short leg is 2, how do I find the long leg, Kara? So short leg times the square root of 3. Short leg times the square root of 3. So that becomes 2 square root of 3. Okay, I think we have one more example like this, yes? Just a triangle laying sideways. Okay, so this is giving me the measurement of the hypotenuse. I know what my hypotenuse is. So this is my hypotenuse. This is my short leg. And this is my long leg. So if I know what the hypotenuse is, how am I going to find the short leg? TJ, pick your head up. If I know the hypotenuse, how do I find the short leg? Divide by 2. So 6 divided by 2 is what? 3. Because remember that the hypotenuse equals 2 times whatever the short leg is. That's how I found that. So basically, I just took 6 and divided it by 2. Okay. But if I know the short leg, can't I find the long leg? The rule says you take the short leg and multiply it by what? Square root of 3. Short leg times the square root of 3. Okay. Everybody flip their pages over. Flip over. So I'm going to go down here to this space at the bottom. And I'm going to draw 2 triangles. Just because I feel like you guys need to have the same information on the same page. So this is a 45, 45. And I know that because the sides are congruent, but I'm also putting angles in there. If this side is A and this side is A, then what is the hypotenuse? What's the rule? Yeah, A times the square root of 2. This is called a leg. This is called a leg. The rule is you take the leg times the square root of 2. Maybe you should write that. Maybe that'll help you process. That's for isosceles right triangles, or 45, 45, 90 right triangles. If I have a 30, 60, 90 right triangle, this is my short leg, this is my long leg, and this is my hypotenuse. 30 and 60 right here. Okay. Well, if the short leg is called X, how do I find the hypotenuse? The hypotenuse is what compared to the short leg? Look at your rule. If you know the short leg, what do we do to it to find the hypotenuse? Multiply by what? 2. So 2 times X. If you know the short leg, what is the long leg? X root 3. So the hypotenuse, I'm going to write it out in words so you can see what's happening. 2 times the short leg. The square root of 3 times the short leg. That's all we're doing, okay? That's all you're doing. If you go back to that last example, the example with 8 on the hypotenuse, I'm just going to go back to that because I want to see if you can come up with a rule really fast. If you have a 45, 45, like this example right here, and you don't know the measurements of the leg, but you know the hypotenuse, we started with the hypotenuse equaling 8. So the hypotenuse equaled 8, and we were trying to find the leg. And we discovered that the leg was 4 times the square root of 2. Could you come up with the rule that says in a 45, 45, Vanessa, open your eyes. In a 45, 45 right triangle, if you know that the hypotenuse is this, what did I do with 8 to make it equal 4 root 2? But it doesn't say 8 root 2. What did I do with the 8 before I multiplied by the square root of 2? Because 4 is half of 8, Quali. Yes. So let's write a rule that says that. Right down here at the bottom of your notes. So this is something that's important. So if in a 45, 45, 90 triangle, you know the hypotenuse, the leg equals 1/2 times the hypotenuse times the square root of 2. So let's draw a picture and see if that makes sense. Let's draw a picture to make it go with our little, So if this is 16 and I wanted to find the leg, I can use the rule that says the leg equals half of, what's my hypotenuse? 16 times the square root of 2. What is half of 16? So the leg is 8 square root 2. Okay. All right. We're going to do examples 1, 2, 3, 4, 5, and 6. And then I'll get you guys back on your test for those of you that didn't finish. To which side? Okay. So let's look at example number 1. I'm kind of smush it over this way so I can do the work off to the right. So whenever you have a 30, 60, 90, I think it's helpful if you label your sides. So this is the short side or the short leg. This is the long leg, and this is the hypotenuse. So short, long, hype. So do we know any measurements at all? Do we know any measurements at all? We know that the long leg, we know the long equals 25. What is the rule to find the long leg? We just wrote it at the bottom. What is the rule to find the long leg? Not for 45, 45, for 30, 60, 90. It's the short times the square root of 3, right? Do you guys see that? Yes or no? Okay. So the rule for the long leg is I take the short leg times the square root of 3. Okay. Well, what is the name of the short leg? It's D. So D square root of 3 equals 25. How do I get D all by itself? Divide by the square root of 3. Divide by the square root of 3. And now what? Do I have D all by itself? I do, except that I cannot leave the square root of 3 in the denominator. That's illegal. Fancy one, multiply by the square root of 3 over the square root of 3. So I have 25 times the square root of 3 over, what is the square root of 3 times the square root of 3? Say again, Quali. Yeah, it's 3. So this is the value of the short leg. 25 times the square root of 3 over 3. You guys see why you can't use Pythagorean theorem here? You're only given one measure. You have to know the rule for special right triangles. You have to know the rule. What about if I want to find the hypotenuse? Can I find the hypotenuse of a 30, 60, 90 if I know the measure of the short leg? What do I do to it? I take the short leg and multiply it by 2. So the hypotenuse equals the short leg, which is 25 root 3 over 3 times 2. So what is 25 times 2? 50 square root 3 over 3. You can't simplify that. You just have to leave that. So that's what C equals. That is C. Okay, let's go to the next one. Oh my goodness. We have a 45, 45, 90. And we know the hypotenuse. I think we wrote a rule for that. That says we can find the measure of the leg if we know the hypotenuse. 1/2 times the hypotenuse, which is 28, times what, Quali? Okay. So what is half of 28? So y equals 14 root 2. Yes, 45, 45, 90s are way easier than 30, 60, 90s. I would totally agree. If someone was going to say that, yes, they are. Okay. Let's go to the next one. We have a rectangle. In our rectangle, we have been divided up into 30, 60, 90s, and I only know the hypotenuse. You see that? I'm sorry, I don't know the hypotenuse. I only know the measure of the long leg. So in order to find the hypotenuse, I have to go from long leg to short leg. We already did that. We did that on example number 1. So how do I do that? Well, the long leg equals the measure of the short leg. I'm going to label it y just so I don't use the same variable, times the square root of 3. Okay? So let's do some math. 14 equals y times the square root of 3. I need to get y all by itself. I'm trying to find the measure of the short leg. How do I do that? Yeah, divide both sides by the square root of 3. So now I've got y all by itself. Y equals 14 over the square root of 3. Can I leave that like that? Can I leave the square root of 3 in the denominator? Nope. I have to multiply by a fancy one. Square root of 3 over the square root of 3. So 14 root 3 over, what is the square root of 3 times the square root of 3? That equals y. Okay. What do I know about the hypotenuse, x, in this triangle, right? The hypotenuse is x, compared to the short leg. The hypotenuse, x, equals what times the short leg? Look at your rule. The hypotenuse equals what times the short leg? 2 times the short leg. 14 root 3 over 3. What is 2 times 14? So 28 root 3 over 3. I know the numbers aren't pretty, but that's how it works. I know they're not pretty, but that's how it works. Okay, let's go to number 4. Number 4. I'm trying to find the hypotenuse. I'm just going to sketch this triangle off to the side so you can see what you have. You have the square root of 2, square root of 2. Here's your right angle. You're trying to find z, your hypotenuse. If you have a 45, 45, how do you find the hypotenuse? What does it say to do? Danae, what does it say to do? When you have a 45, 45 right triangle and you're trying to find the hypotenuse, what are you supposed to do? Take the leg and do what, TJ? Take the leg and do what, Eden? Take the leg and do what, Kara? Yeah, you take the leg times the square root of 2. So the hypotenuse equals the leg times the square root of 2. This is my leg, and this is the rule. You guys see what I'm doing there? So what is the square root of 2 times the square root of 2? 2. So z equals 2. And that kind of makes sense because I said if you know the hypotenuse and you divide it by 2, what's 2 divided by 2? 1 times the square root of 2. Don't you get root 2? Yeah. You guys are getting caught up on the fact that you're working with radicals and just not thinking about the math. So here's a 45, 45, 90 right triangle. You don't know the leg. We're going to call it S. You do know the hypotenuse. So let's see. The leg equals what? What does the leg equal? What does it say? We wrote it down. I made you write it at the bottom. If you know the hypotenuse, how do you find the leg? 1/2 times the hypotenuse times the square root of 2. Polly, what is half of 6? So the leg is 3 times the square root of 2. Do you see that you're not given 2 points, 2 measures on your triangles to use Pythagorean theorem? That's why you have to know the special right triangle rule. It's going to save you so much work. Okay, this last one is a little bit tricky because it's a trapezoid. It's a trapezoid, but we know that trapezoids have parallel bases. So if this height is 2 root 3, then this is 2 root 3. And this is my long leg. So the long leg is 2 root 3. This piece right here is my short leg. And this is my hypotenuse. So if I know the long leg, how do I find the short leg? How did we get the long leg? What did we do to it? We took the short leg times what? We wrote it right here. I'm struggling to figure out why we're times the square root of what? Yeah, we take the long leg is the short leg times the square root of 3. Square root of 3 times the short leg. Okay. So if I know what the long leg is, I took the short leg and I multiplied it by the square root of 3. So what is the short leg? What do you see that you have on both sides? Divide by the square root of 3. What is the short leg? Short leg is 2. That means this piece right here is 2. This measure of 5 is for the whole side. Don't be fooled by that. So if that short piece is 2 and the whole side is 5, what is this measurement? Which is the same thing as this measurement. Look at what I'm saying. This whole side over here is 5. But I know that this short piece right here is 2. Yeah, B equals 3. So since I know my short leg, can I figure out what my hypotenuse is? How do I find the hypotenuse? The short leg times 2. So the hypotenuse, A, equals the short leg times 2. So A equals 4. A equals 4. Okay.